intermediate theorem. So this one just same as the previous one. So I think no need to show you again. So already for the intermediate theorem, just the same thing. Prove that the value of function for the initial value and n value that is less than 0. So now we try to solve it using the Newton-Raphson method. So just the same thing at here, the functions x squared minus sine x against the things that at here as the trigonometry function. So remember that shift your calculator to the radian mode, and then how to get the exact roots at here. So from here again, the same thing, you just insert e as x squared minus sine x into your calculator, and then you just press shift calculate. So you will get e, the roots. That is something like 0.x. X something is it? X7 something, X6 something, okay? So for this one, based on the interval, you know that 0.x something that is nearest to the value 1 as compared to 0. So that is why we choose the initial guess as 1 at here. This one for the Newton-Raphson method is different with the bisection method. If for the bisections method, if let's say that the interval it asks you to do the calculation, the difference at here as 1. So you know that AI you choose 0, BI you choose 1 at here. Since at here it didn't mention the conditions of this one, so you may just refer to the interval as given at here 0.5 to 1 to proceed the calculation if let's say that for the bisection method. So remember that if let's say that the conditions is given, please use 0 to 1 since at here that fulfills the conditions, the difference equals to 1. If this one is not discussed at here, you may just refer to the interval at here, you just use that 0.5 to 1. For sure, the starting interval, the shorter the starting interval, the faster the iterations you can obtain the approximate solutions at here. And then for the bisections method, so just the same thing, no, just not bisection method already. Okay, so if let's say that for the Newton-Raphson method, so for the Newton-Raphson method, just the same thing. So Newton-Raphson method, you no need to choose both interval at here. For the Newton-Raphson method, you just use that the point, the initial guess, that is the value which is nearest to the exact root at here. So as refers to here, the exact root that is 0.x something that is nearest to 1. That is why we choose the initial guess as 1 at here. You want to choose e as 0 is also acceptable at here, but for sure, maybe you will get most, how many iterations? I have a try already. Maybe you have to do the iterations until iteration 6i equals to 6 in order to obtain the approximate solution. If you use the value of x that is equals to 1 as the initial guess, you can get the answer in I equals to 2. So there's just the third iterations you are able to get the answer already. So just the same thing. If you are unable to determine the initial guess, up to you. You want to use 0.5 or 1 at here since the interval is given at here. But against that, just a simple thing, insert the function and then press shift calculate. If you are unable to get the roots, maybe at here you didn't insert the bracket since up to the versions. If let's say that you use the latest 2 versions, the side bracket is automatically available on your calculator once you press the sign at here. If you use the old version, maybe you have to insert the bracket before you insert the x at here in order to get the answer. Okay. So from here, the functions given f of x equals to x squared minus sine x, just insert into your calculator. From here, you know that the derivative, which is same x, 2x minus cos x. Just do the derivative based on the previous one, and then so something is better, then I just write it. Okay. So again, the same thing, derivative of sine x, you will get it as a cos ax. So that's why in the end you will get this one. And then I want to share with you. Okay, against the thing, if you are unable to do the derivative, you just insert it. Okay, how to get the derivative symbol at here? Just press shift and then press the integrations button. You can get this one, and then you just insert it the function. So there is x squared minus sine x, and then at here x equals to x. We just insert the alpha x at here. So you are going to get the derivative of this one. Okay, but for me, I just do it manually. If you use this one, remember they write down the manually if you are able to get it. And then, okay, if you are not confident with the derivative, maybe you can use the built-in functions in your calculator. And then for the Newton-Raphson method, so Newton-Raphson method, just the things that you are going to use a minus b over c, since there is xi plus 1 equals to xi minus fx over f prime x. So again, it's the same thing. This one is a, b, c. So initial guess, I choose it as 1. You want to use the zeros or you want to use the 0.5. This also is acceptable, but for 0.5, you will get it in I equals to 6. So against the thing, just remember that choose the nearer point to the exact roots. So just remember that the difference at here for the shift enter, that means that you are going to get the exact roots. If you use the shift calculate, you are going to get the exact root. If you use the calculate, that just substitute the value of x in order to get the value of y. So just the same thing as refers to here, insert into your calculator, and also this one, insert into your calculator. So once you insert this into your calculator, you just press calculate. You may substitute the value of x equals to 1 into your calculator. So you are going to get the value 0.1585. And then again, it's the same thing, insert this into a calculator, press calculate also. The first derivative you get is 1.4597. Then just insert the formula for the Newton-Raphson method as refers to here. Insert the value A, B, C into the calculator. So the latest value of x is 0.8914. Once you insert it against the same thing, just find out the previous insert. Okay, no need to clear the thing. Find out the previous value of functions. Now you press calculate, and then now's the value of x as 0.8914. So you just substitute the value. You just press the equal sign. So the value of x now as 0.8914. Against the same thing, find out these equations, press calculate. Now the value of x which is available on your calculator already. So you get yes 1.1545. So just the same thing. Remember that we just refers to the latest previous row. So now the value of A, B, C, it becomes in this way, and then as you check it here, so this one is greater than the epsilon number. The difference in between here, that is greater than the epsilon number also. So that means that you have to proceed the calculation. Just same as the condition for the stopping criteria. And then for the next iteration, so now the value of A, B, C equals to this one. So that means that once you substitute the value of A, B, C as refers to the formula of Newton-Raphson method, you get this value. So, and then the value of function 0.0003. So how I know that this one is 0.003, since in your calculator you may get it in this form. So remember that -4, that means they move forward 4 digit, 1, 2, 3, 4. So 0, 0, 0 at here, 0. Okay, where you stop, put the decimal places, so which is same as 0.003. Since this one is 0, previous one no need to plus 1 at here. So this one, as you notice at here, there is less than the epsilon number 0.005. And then another thing is that, as you notice at here, the stopping criteria is not mentioned, is it? Yeah. Okay, it's not mentioned, so we just do the calculation in 4 decimal places as the questions mentioned. So we use the general stopping criteria, just 0.0005. And then actually for these questions, you no need to find out the exact root. You no need to calculate the shift calculate, since the exact root is given in these questions. Okay, so as you notice here, x 7 point something, that is nearest to the value of 1 at here. And then once you get it against the same thing, just write down the conclusion. Just remember that for the stopping criteria is the value of functions that equals to 0 or less than the epsilon number, or the difference in between the latest value of x and the previous value of x, that is less than the epsilon number also. So here the value of functions is achieved first, so you just write it down. Against the same thing, the important thing is they write down the stopping criteria. So the key points at here is the stopping criteria and the value of function. The stopping criteria, and then as you notice here, the stopping criteria is achieved. So that means that this one is the approximate solutions you obtain. So for sure, the approximate solutions you obtain, which is approximately same as the exact roots. So the approximate roots for sure, which is same as the exact roots, as you notice at here, 0.86 something. So at here 0.8770. So which is not normally not exactly same, since the routing of error, but for sure you can get it as approximately same at here. If let's say that you get it as 1.87 something, please recheck your answer for sure. Maybe you do some, maybe you just did some mistake here. Okay, for sure there is approximately same, maybe different 0.003, 0.005 something at here, but for sure we think one. If not, please recheck your answer. If the difference at here is quite rush, maybe you did some mistake here. Okay, so this one, that's all for this example. L, no yet. So at here, the question asks you to calculate for the absolute error. So for the absolute error, just the same thing. Remember that it's better that you write down the formula, or you just want to substitute the value directly, is also acceptable. So the important thing is that you show me the formula before you proceed the calculation. Since at least you did the mistake, I can give you 1 mark for the formula. So at here, just the thing, insert it, that equals to E minus F, B equals to A over E. And then you press calculate. So from here, you know that the exact value which is as the exact solutions as from the questions it given there. Okay, the question given, we just use it, and then the approximate solution 0.8770 we obtain it here. So just substitute the value, you may get E, which is equals to 2.7 times 10 power negative 4. Up to you if you want to write it in this form. Normally, you no need to write it down. Okay, in case that you want to write it down to expand it. So again, the same thing, 1, 2, 3, 4. So 0 0.0002. 1, 2, 3, 4. So that means the truncate here greater than equals to 1. Previous have to plus 1. But for me, you just write the answer from the calculator. This one is acceptable already. Another one, x minus x approximate times 100%. So, okay, so that means remember that for this formula, the answer which is not in percentage, that means that once you get the value, you have to times with 100%, so you will get it as 0.0308% here. Okay, so as refers to here for the bisection method, okay, just as a recall for you, from the bisection method, you get the absolute error as 0.0140. For the reactive error percentage, that is 1.59%. So that means that from the Newton-Raphson method, both absolute error or the reactive error, that in percentage that is smaller. Okay, in these questions, it doesn't ask you to justify the question, just something I want to share with you that as you notice that here the value for the absolute error and the reactive error in percentage that is smaller as compared to the bisections method. That means that if let's say that the question asks you to justify it, you may just write it down, okay, the value is smaller or bigger or larger, up to you, the words you want to use. So you can conclude it that more accurate, since for sure you know that the value of absolute error and the reactive error is smaller. That means that more accurate as compare here. So that means that Newton-Raphson method is more accurate as compared to the bisection method. Okay, just something I want to share with you. Actually, in this question, didn't ask you to justify it. And then the next one. Okay, faham tak? Nak tanya apa-apa tak? Tuan tanya, proceed the next one. Ya, nak tanya apa? Ada orang buka mic kan? Okay, so it refers to this one, draw the graph. So how to draw the graph, I share with you already. So based on the interval here, maybe you just substitute it x equals to 0, x equals to 1, x equals to 2, x equals to 3, x equals to 4, x equals to 5. And then you may get the value of x. So once you get value of y, so once you get the value, that means that you can just plot the graph since x refers to here, the interval that is 0 to 5. Again, it's the same thing as you notice here is the trigonometry function. Please make sure that your calculator in radian mode. So this is the way how to sketch the graph. And then another things that I want to share with you is, let's say that the question give you two functions g of x and h of x, and they ask you to plot it on same plate at here. So if let's say that for this one, you just plot this graph and then plot this graph and then show me the intersection point in between here. So how to get the intersection point? F of x equals to g of x minus h of x. So insert this one and then you press shift, calculate just the same thing. So you know that where is the exact root in between here. And then what I want to share with you. Okay. So at here, since there is only one graph at here, so you just plot this one, use some value and then plot it. So this one for 4 marks. And other things that I want to share with you, if you want to plot the graph XY, maybe you are unable to plot it at least at here, at least just have a try at here. And then, well, okay, so if you're unable to draw it, maybe you just draw the edges first. Maybe, how knows, maybe here there is 1 mark. Okay, and the intermediate value theorem. So again, the things, the value of function for the initial value and the end value that is less than 0, as refers to here. It mentions or not. Okay, it didn't mention that the didn't mention it. So if you want to use f of 0 times f of 5 less than 0 is acceptable at here, since that at here didn't mention that b minus 1 have to equals to 1, but normally we just refers to this one. So once you plot the graph, you know that where is the value is better, that you just based on the interval a to b in order to get the value. And then again, the same thing, solve it using the Newton-Raphson method. The epsilon number equals to this one. Justify your answer with using the calculator. And then as you notice here, this one asks you to solve for the positive roots. That is why the roots which is belongs to 0 to 5 at here. So the first thing at here, try to plot the graph. So from here, just you insert this equation into a calculator, you may get the value of functions as -2, -0.0907, 1.2432. If let's say this one that is 22.4560, and then these two 6.7206, and then this one 14.9894 here. Okay, you get the value, and then you may just plot the graph. And remember that for the nonlinear equation, you just plot it using the curved line. Don't connect it using the straight line. You just draw the curve since this one is the nonlinear equation. Okay, so based on the value at here, we draw the graph x, y, and then when x equals to 0, this one is -2. And then, okay, just draw the scale at here as logic. But when value x here is 1, maybe negative point something. So let's say that here, oh no, it's not logic. Okay. And then when this one is x equals to 1. So when x equals to 2, 1.2 something, when 3 is it 1.2 something, let's say here. So 6.7 something, let's say here. It is 14 something, let's say here. And then 22 something. Okay, please try to draw it logically. For me, you just sketch it, maybe use it 1 cm equals to 2 unit at here, up to you. The important thing is that at least there is logic. Okay, don't follow me at here, and then remember that don't connect it with using using the straight line. Okay, since at here this one is the non-linear, so just connect it using the curve. So just connect it. Yeah, don't follow me, connect it nicely. Okay. Okay, at least better. Okay, remember that don't connect it using the straight line here. So this one for the graph. So based on the graph, as you notice at here, the roots, which is, since this one is only one graph only, so that means that the exact root is the roots on the horizontal axis at here. So there is in between 1 to 2. So I use this one to show the intermediate value theorems. Actually, if you want to use 0s to 5 to show it is also acceptable at here, since the question didn't mention the difference in between the initial value and the end value should be equals to 1. So up to you. For me, I just choose it as f of 0s, f of 1. F of 1, f of 2. So again, it's the same thing, insert the equations into your calculator, and then you press calculate, you may get this value. And then for the another one, you insert it, you may get it as this value. So remember that x refers to the equation, f of x equals to sine 2x plus x squared minus 2. Please remember that your calculator in radian mode, and then you just press the calculate button. So just show me the value and then write it down the conclusion. So this one for the intermediate value theorems, and then we proceed to the Newton method. So f of x equals to sine 2x plus x squared minus 2. And then the derivative, just try to do the derivative equals to 2 cos 2x plus 2x, derivative of the constant equals to 0. Again, the same thing, or you may use the calculator formula. So the derivative of this one, sine 2x plus x squared minus 2, x equals to x. In order to get the derivative, if you are unable to do the derivative, you may use the built-in functions in your calculator. For me, I prefer to show it manually. Normally, there is 1 to 2 mark for how you do the derivative. In case that you're really unable to do it, just use your calculator. Okay, so for the initial guess at here, as you notice at here, actually for this function, if you press the shift calculate in order to get the exact root, so as refers to here, the initial value is 0, so maybe the x value, you just have a try that x equals to 0. The calculator will show you that there is 1.0x something. So 1.0x something, you know that there is nearest to 1 as compared to 2. So that is why we choose x equals to 1 as the initial guess as compared to the value of 2. Again, the same thing, if you want to use when x equals to 2 is also acceptable. For sure, the longer iterations you have to calculate. So against this one, and then you just use the formula a minus b over c. So a, b, c, I repeat many times already. Okay, so I want to share with you. Against the thing, insert the value of function and then press calculate, insert when x equals to 1, get this value, and then insert the derivative. Again, press calculate the value which is available on your calculator already, you may get this value, and then insert this calculator formula a minus b over c, you may get this value. Against the thing, press the arrow button to find out this one. Now the value of x as this one, insert it, press the equal sign, you get this one, and then find this function, and then press the calculate. So the value which is available on your calculator already, you may get this value. As you notice at here, the value that is greater than 0.005. So we just proceed the calculations. Okay, yes, 1.0821 negative 0.00002. As you notice at here, this value 1, 2, 3, 4. So that is less than 5. So previous one, no need to plus 1, which is 0.00, negative 0.00, actually, which is same as 0.0000. So that means that, since remember that we only consider the magnitude, remember the absolute sign. So this one, that is less than the absolute number 0.005 already. So from here, against the thing, you have to write it down, the conclusion. Okay, against the thing, the important thing is that the stopping criteria and the value obtains here. So that's all for chapter 2. Now we move it to the chapter 3, the first method, Gauss elimination. Okay, that I will proceed that.
Boleh, Ustaz.
Okay.
Boleh Doktor.
Okay. Kalau tak faham tanya kalau I laju sangat bagi tahu. Okay, so chapter 3, Gauss eliminations method. Actually, for the system of linear equation, let's say that, okay, again, it's the same thing I want to discuss with you all. What is the thing? Let's say that x1, something x1 plus something x2 plus something x3, same goes to here. x1, x2, x3. Okay, maybe some value at here, plus 9 or minus 10. Okay, some coefficients at here equals to something, equals to something, equals to something. So this one in matrix form, you are able to write E as A, X equals to B. So this one as the matrix A, we just call it if for this one, that means that you just write E as A at 9, and others value at here, and then the x variable x1, x2, x3 at here equals to some value at here. So for the B, normally we just call it as the right hand side. If, okay, I just show some example at here. Okay, so maybe 10, 15, 5 at here. So this one is the right hand side, just as a recall for you. Okay, so we call this one is the matrix A, and then this one is the right hand side, the value of B. And then if let's say that for me, I prefer to write it as the augmented matrix. So why is the augmented matrix? So augmented matrix, that means that you just combine the matrix A and the right hand side. So just separate it using line at here. So this part is the matrix A, this part is the right hand side. So this one we call it as the augmented matrix. My writing is terrible. Okay, augmented matrix. Okay, so let's say that maybe you have to order the material, so you get the variable. Let's say that what is the thing? Maybe the material A, material B, material C at here, and then you have to decide if the total of the variable which is equals to something. So in the end, you will get a system of the linear linear equation. So you are able to solve it using the method we discussed it in this chapter. So in this chapter, there is the Gauss eliminations with partial pivoting. So again, the same thing for the partial pivoting. The difference here is that you have to rearrange the equation before you proceed the calculation. If for the Gauss eliminations, you just proceed to the calculations directly. And then for the Kolesky method, the condition set here is the symmetry positively finite, Thomas method, tri-diagonal, Gauss-Seidel iterations as the diagonally dominant. Doesn't matter, we will discuss it one by one here. So for the Gauss eliminations, only 3 possible solutions. So in our syllabus, we only consider the unit solutions with using the matrix as the square matrix. So square matrix, that means that there is n times n matrix. So let's say that 3 times 3 matrix, 2 times 2 matrix, and 4 times 4 matrix. The dimension for the row and the column is same. We call it as the square matrix. So n times n at here. So if you use the latest versions, you are able to solve it until 4 versions with using your calculator. So if let's say that you use the silver one or the old versions, you are only able to solve it out to 3 dimensions only. And then in our syllabus, you only consider the unit solution. What is the unit solution? Unit solutions, that means that you are only able to get one value for each variable at here. In finite many solutions, maybe you can get more than one solutions at here. This one, which is not in our syllabus. and no solution which is not in our syllabus also. So that means that you are only able to get only one value for each unknown here. Okay, so the first one, the theory for the Gauss elimination. So just against the same thing at here. So let's say that this one is the what is the thing? Okay, you may just write it as the matrix form. So this one is the example just now I show you. So matrix A, we using a line separate it with the right hand side. This one we call it as the augmented matrix. So you may just write it A11, A12, A13 in matrix form. You just write it down. So that means that this one is the matrix A, and then the right hand side B, you just write it down. So actually for this one, which is AX equals to B. So in order to eliminate the elements below the main diagonal, so against the thing, just as a recall for you, this one we call it as the main diagonal for this part. Below it, we call it as the lower diagonal, and then above it, we call it as the upper diagonal here. So for the Gauss eliminations method, actually this one just use it to solve the to eliminate the elements below the main diagonal. That means that we are going to make this one, and this one as 0. So in order to make it as the upper triangular matrix. So how to do it? Just remember that the formula that is negative, the coefficients you are going to eliminate. Okay, so for the numerator, that means that the coefficients you are going to eliminate. Okay, so here we want to eliminate the elements below the main diagonal. So for the first one, that means that A21 over the denominator as the value for the main diagonal as refers to this column. So this one is the main diagonal elements. Okay, and then multiply with, so for the value at here, which is related with this one. So the main diagonal elements which we form row 1, so that is row 1 plus this value just related with the numerator, so you are going to eliminate. So this one is refers to here as row 2. So this formula is going to be the latest value for the row 2. Just the way how I remember the formula, but no worry, when you're familiar with the calculation, this formula just the easier things. And then again, the same thing. If let's say that you done the calculation for this one already, we proceed to the next one. Now you are going to eliminate the value for the A31. Again, the same thing. Negative A31 as the coefficients you are going to eliminate over the main diagonal element. So as refers to this column, the main diagonal is A11. So A11. This one related with this one, so as refers to here, A11 from the first row, so R1 plus refers to the numerator. Numerator is refers to here as the third row, so R3 is going to be the latest row. So once you apply the calculator formula as refers to this here, for sure you are able to get the value at here as 0. Since this, the purpose of these two formula is going to eliminate the elements below the main diagonal. Okay, so we just proceed to the first example. If you are confused now, just ignore it first. Okay, and then what is the thing? So for the calculations, normally we just refer it as A, B, C at here. So there is why for the first row, when we use the calculator formula, we just use it as A. The second row we use it as B, and then the third row we use it as, okay, maybe refers to here it is define it as the new row, but for me normally I just use the same thing, A, and R3 as the C at here. So I know that A stands for the first row, B stands for the second row, and C stands for the third row. So up to you, you want to use the others variable X, Y, Z is also acceptable. The first thing is that please don't confuse with the variable you are going to use at here. Okay, first example. Okay, so from here against the thing, for me, I prefer, okay, don't ignore the right hand side. So that is why the importance of the augmented matrix, since we do the operations, we change the value for the left hand side, the value of the matrix form, the value of right hand side is going to be changed also here. So that is why against the thing. So the first thing is that please write E in matrix form. So to write E in matrix form, I think this one just a simple thing. You may know it, 3 negative 15. Okay, so this one stands for the A. Okay, so 4 negative 2 9. Okay, so remember that for the augmented matrix, you just write A and then B at here. So the value at here, so from here, you know that this one stands for Y, X, Y, Z. So just write down coefficients at here. And then same go to here, just write if negative sign, just bring down the negative sign. So I should first to here, this one is the main diagonal. And then, so if you want to eliminate this row, that means that the as refers to the formula, remember the negative sign from the formula. So you are going to eliminate the elements 2 here. So 2 over 1. So remember that this one is the elements you are going to eliminate. As refers to here, the diagonal elements as 1. So the diagonal elements from here as from the row 1 plus the value from the numerator from row 2. So it's going to be the latest second row. Up to you, maybe you found somewhere to remember it. You may just refer to your own way. For me, I just remember it in this way. So that means that once you want to insert, actually you don't want to write as row 1, row 2, so doesn't matter. You may just refer it as A, B is going to be the latest second row here. Sorry, this one is correct. Just I want to write E a bit left here. So negative 6. 2 over 1. Yeah, let me stay here. Okay, just same as just now. So this one for the operation for the second row, if let's say that you want to eliminate the third row, so negative, the elements you are going to eliminate. So negative 6 over the main diagonal elements at here, you know that there is 1 is going to be R1 plus R3 is going to be the latest third row. So again, the same thing, numerator refers to this one. Okay, so it refers to here, you may use E as A, B, this one as A, C. Since at here, you may just denote E as A, B, C at here. So that means that you just insert this calculator formula into your calculator, negative bracket 2 over 1 alpha A plus alpha B into your calculator. This one just the same thing, negative bracket and then alpha A plus alpha C. So when you insert into your calculator, this one in this form. Okay, during exam, no need to write this one to me, up to you. You want to use the variable R1, say here, we just write ESA, up to you. So during when you want to insert into a calculator, maybe you just write the small a, b outside the equation. So you no need to rewrite the equation for the calculator formula. So this one is going to be the letters 0, and then this one is going to be the letters 0. Okay, so when you insert into your calculator, just insert this part. And then for the matrix, so just the things that, so these two equations going to eliminate the elements from the second row and the third row only. So for the rest, you just rewrite it. Okay, so first one, you rewrite it first, and then you insert this into your calculator. Once you insert it, you press calculate. So when you press calculate, now you just insert the value of A and B here. So you just once you insert these equations in your calculator, press calculate, then you insert the value of A equals to 1. Okay, since A just refers to here, the value of B as 2, and then you press equal signs again. For sure, you will get E as 0. If this value is not equals to 0, please recheck your equations at here. Maybe you insert the wrong value, or maybe your calculator formula at here is wrong. Since the purpose for these equations in order to eliminate the elements at here, which is equals to 0. Okay, if let's say that you get it as zeros already, so you just move it to the second column. Okay, so now the value of A as negative 3, the value of B as negative 8. So just use the same equations. Okay, so remember that for the equations, you are going to eliminate the elements below the main diagonal. You just do the operation for the whole row here. So for the row 2, you just do all the operations at here. So now when we move it to the second columns, you know that the value of A is negative 3, the value of B as negative 8, and then you just press the equal signs. You may just get it as negative 2 at here. Okay, against the same thing, once you get the value at here, just refers to here. Now it's the value of A. Okay, just refer A refers to the first column. So now we proceed the calculation for the third column at here. So the value of A is 1, the value of B is 8. Against the same thing, you press the equal signs, you may get the latest value at here as 6. Okay, remember that same go to the right hand side. So you just refers to here. Now the value of A is 4, the value of B is negative 2. So you may get E as negative 10. So this all for the first formula here. Another ones, we just insert this into your calculator. Just try to insert it now. Against the same thing, once you insert this formula, for sure you are going to get this value as 0. If not, we check the calculator formula or the value you insert here. Okay, you just insert this into your calculator and then press calculate. Just the same thing. So it refers to here. Now the value for the first columns, the value of A is 1, the value of C is negative 6. For sure, you will get E as 0s. If not, just recheck the calculator formula or the value you insert before. Okay, once you insert it against the thing, remember that you not only do the operation for the first column only, so just for the whole row here. So refers to the second column. Now the value of A is negative 3, the value of C is 3. So just insert it How I know that I need the value of A and C only? Since as refers to the formula, we are going to use the value from the first row and the third row. So A equals to -3, C equals to 3. You may get it the value of -15. And then we move it to the third row. So the value of A is 1, the value of C is -15. So you may get E as -9. Okay, have a try now. And then the last one, so as refers to the right hand side, the value of A is 4, the value of C is 9. So you may get E as 33. Okay, so the common mistake here is that sometimes students do the operation for the left hand side and then maybe forgot the right hand side. So please remember that you want to do the operation. Remember that mathematics is fair. So when you do the operation, remember the whole things at here. So once you do the operation for the matrix, remember the right hand side at here. So that means that you get this one as the latest version for the matrix form. So as refers to here again, the same thing, you are going to eliminate the elements below the main diagonal. So as you notice here, this for the first column is done here. So now we move it to the second column. As you notice here, the second column is just the only one elements here. Okay, so again, the same thing from the formula. Okay, don't ask me why I got this formula. It changes from the formula since in our syllabus didn't discuss the derivative. So negative bracket, so the element is going to be eliminated. Okay, this element is going to be eliminated. So -15 over the diagonal elements. So as refers to here, this one from the second column. So the diagonal elements as -2. Okay, and then so as refers to here again, the same thing, diagonal elements from the second row. So R2 plus -15 forms the third row. R3 is going to be the latest third row here. Again, the same thing, just use the variable B, and C is going to be the latest third row here. And during exams, you just insert this part into your calculator. Okay, no need to rewrite it as the calculator. Don't waste your time. So this one insert into your calculator. So just the same thing. So maybe if you want to have a try also can. So once you insert this into your formula and then you press the calculate button. So for the value of B, when B equals to 0, C equals to 0, for sure you get yes zeros again. Okay, and then we move it to the second column. So when B equals 2, so again, the thing, if you are confused, maybe you can write it A, B, C. And then, so here, when B equals to -2, C equals to -15, for sure you will get it, this one as 0. If not, again, the same thing, we check the calculator formula or the value, you insert it at here. Please refer to the correct row at here. Okay, so let me to write. Okay, so again, the thing for the matrix form. So now we do the operation for the third row. That means that for the previous row, you just write it back at here. Okay, just write it back. So when you insert these equations into your calculator and then press calculate, so when value of B equals to 0, C equals to 0, for sure you get yes 0. And then we move it to the second column. So when B equals to -2, C equals to -15, for sure you will get yes 0. If not equals to 0, we check the equations or the value you insert here. Once you get the value, press it again. When B equals to 6, C equals to -9, you will get it as -54. See, I made a mistake here. Seems like I made a mistake here. Is it this one should be 3? 诶，第一个读出不 Let me a while. So here negative 2 over 1 plus c. Let's calculate. Negative 3, negative 8, negative 2. Calculate. Negative 3, negative 8, negative 2. So this one is correct. Until here, this one is correct also. Okay, so once you insert it, and then you insert this one, you get e as negative 14, and this value as 108. Okay, yeah, all the things correct here. So when you get this one, as you notice it here, the elements below the diagonal, all the elements at here is zeros already. So you may rewrite it in equation. So as refers to here, the variable using as x, y, z. So you just rewrite it as as refers to the first row, so x minus 3y plus z equals to 4, as refers to the second row, negative 2y plus 6z equals to negative 10. And then from as refers to the third one, negative 15, 4z equals to 108. So from here is 1, 2, 3 equation. Okay, just rewrite it in equation form, and then from here we apply the backward substitutions. How I know that this one is the backward substitution? Since I refers to the last row, last equations at here in order to get the subsequent previous one and also the subsequent previous two equations at here. So from the third equations, you know that z equals to 108 over negative 54, which is equals to negative 4. Okay, actually during exam, no need to show me this one, just show me directly. The answer is acceptable. And then once you get the value of z, you just substitute it into the second equation. So negative 2y plus 6, negative 2 equals to negative 10. And then just rearrange it. Okay, here maybe I show you one of the example. Negative 2y equals to negative 10. Negative, move it to the right hand side, become positive plus 12. So y equals to 2 over negative 2. Okay, multiplication, move it to the right hand side as the division. So 1 by 1. Against the thing, you just apply your calculator. Okay, try you just up to you. For me, maybe the simple thing, I just calculate it manually. If you are not confident with the thing, please just use your calculator to get the value. And then once you get the value of y, just substitute it into the first equation. So x minus 3y plus z equals to 4. As refers to here, the first equations. Okay, so from previous, you know that z equals to negative 2, y equals to negative 1. So just substitute the value. So again, it's the same thing, just rearrange it. So x minus 3, negative 1 plus Okay, against the thing, no need to show me these calculations there. We just, if you are able to get it directly, so x equals 2. So for this part, negative, negative, positive 3 minus 2 equals to 1. So 1, move it to the right hand side as 4 minus 1, that is equals to 3. So that means that you get all this value, and one more thing that during exam is better that you rewrite it in column, easier for me to mark it. Okay, so x, y, z is refers to here, x equals to 3, y equals to negative 1, z equals to negative 2. Another things that I want to share with you, there is some tips maybe I can share with you that since based on the questions, you know that the equations that is in form of, okay, for this matrix actually which is in form of A, x equals to b. So maybe you can insert the matrix into your calculator as the matrix A, and then once you obtain the value of x at here, so just insert it as the, let's say that the matrix C. So just try to do the matrix multiplication. For sure, the matrix multiplications of matrix A and the matrix C will get it the value same as the right hand side. So how to insert it? Now I share with you how to press the calculator. If you use the silver version, so just press mode and then you choose 6, since 6 at here, as you notice at here, you write it as the matrix. So from here, so matrix A, you just choose 1 as the matrix A, and then the dimensions at here is 3 times 3, so that means that you just choose the first one, insert all the value at here as the matrix A, and then for the value of here, as you notice at here, 1, 2, 3, so that means that there is 3 times 1 as the vector. So against the thing, you just press mode 6. Up to you. Actually, there's a lot of way you may get it. If you want to use another one, you may use the shift 4. So shift 4 2. This one is the data, or maybe just the same thing. You use the same one, mode 6, and then now you choose 2 since for the B, and then here as 3 times. Maybe you are confusing, so it's better that you choose 3 as the matrix C, since I scare you confused with the right hand side, the variable B here. Okay, so here the vector as 3 times 1, you just insert the 3, so insert all the thing. Okay, once you insert it, and then you just how to call out the matrix A. So shift 4. So you just insert the variable 3. So this part is the way how to call out the matrix A. And then another one, since we insert it as matrix C, so shift 4, 5. So this one, how the way to call out the matrix C. So once your calculator, the screen show you that matrix A, no, it's not the matrix. The calculator will show you that matrix A, matrix C. So you just press the equal sign bottom right one, the bottom right one, the equal sign. You just press it, the equal sign bottom right button. Okay, you may get it for sure the value which is same as the value of B. The value of B at here is 4, negative 2, 9. Okay, since matrix A, oh yeah. X equals to B. So that's why the matrix multiplication for the right hand side must equals to the right hand side. So this one is one of the way you may check your answer. Another one is that just some sharing with you, okay? So in order to get the value of X, actually we apply the inverse transform. So A inverse AX equals to A inverse B, okay? Just multiply with inverse of A on the both sides. So for this one, based on the matrix, you know that inverse, the matrix multiplication of inverse and the matrix, you will get it as identity. So identity X equals to inverse AB. So from here, you know that X equals to inverse A multiplied with B. So that means that again, the same thing, once you press the matrix in your calculator, when you call out it, you just press the button H power -1 at here and then multiply with the matrix C you insert before, you will get it the value of X, which is exactly same as this one. Okay, actually this one just all the thing from the textbook. Maybe you just refers to the textbook as a recall for you. So remember that if you want to check your answer, maybe you just check if using the left hand side equals to the right hand side or applies the inverse properties. So you get it as you just insert the matrix A and B into your calculator in order to check the value for the variable X, Y, Z here. And then another one, if you use the latest version, wait me a while. So if you use the latest version, against the same thing, both way you are able to solve it. So I just share with you how to press the calculator. So when you press the menu, okay, press menu and then you just choose 4. 4 here stands for the matrix. So just the same thing, define that matrix A. So just press 1 for the matrix A. So at here, this one is 3 times 3 dimensions. So number of row, you just press 3. And then number of columns, you press 3 also. Okay, and then you insert the value. And then ops 1. Okay, now so you insert ES matrix 3. So that is why the matrix C at here. So insert the value at here. This one is the vector. So 3 times 1. Since there is 3 row and 1 columns, insert all the value. And then against the thing, you just press Op. So Ops at here, Ops 3, and then Ops again, Ops 5. Okay, this is the way how to call out the matrix A and the matrix D. So the matrix multiplication set here, you just press the equal sign, the right button, you will get either value which is exactly same as the right hand side. So like what I mentioned just now, AX equals to B. So that is why the matrix multiplication of left hand side equals to the right hand side, the value of B. And same go to here, X equals to A, the inverse matrix of A and B. So against the same thing, when you call out the matrix A and then you just press the button, the inverse button at here. So the matrix A with the sign -1, and then matrix C, when you use this matrix multiplication, for sure you can get the value of X based on the properties for the inverse transforms. So just the same thing, this one is first of the way, this one of the second way, maybe you can have a try. In order to get the value, you are able to use this way to check your answer during exam. Okay, So maybe due to the time limitations, I leave one example as your exercise. Maybe you just have a try on your own. Another one I discuss with you now. Ni faham tak?
Paham.
Faham ya? Okay.
Faham betul?
Faham ya? Okay. So maybe I am unable to show you using the software since maybe some problem with it. So just the same thing. If you are confused with it, maybe after the class, you just stay a while. I show you that how to do it step by step. Another thing is that if you use the version I don't have, please show me your calculator. Maybe we can explore together. Okay, so that's all for this one. And then what is the thing? Okay, for example, 2 just refers to the slide. You may have a try on your own due to the time limitations. Maybe I am unable to show you all the example at here. What is the thing? Okay, so this one, maybe you can have a try on your own. At here, I just write it down the value. After you have a try, maybe you can compare your answer with my answer. Okay, just remember that have a try on your own. If not mistaken, this answer is correct. Now we move it to the last example for today. Okay, actually this one just same as the, what is the thing? Okay, just same as one of the example from the textbook. If you are unable to get it, maybe you just refers to the book. Actually, I know that maybe someone didn't buy the book, doesn't matter. Maybe you can ask your friends whether they can take the photo for this example for you to let you have a check for it. So up to you, you want to buy it or not. But for me, it's that if you are unable to buy it, maybe for the exercises, you just ask your friends. So there's a lot of exercises from the book, or maybe you just I'm not good to say in this way. Okay, so just try to do the exercises together. Okay, just the same thing as refers to here. It used okay against the same thing. Please don't follow the decimal places at here. Since for the calculations, you have to standardize the decimal places. So let's say that the questions didn't mention. Okay, so something I want to share with you. If let's say that for the table, I prefer to use 4 decimal places. If let's say that for the equation, if you want to write it in fractions, if let's say that you are able to write it in fractions, you just follow it. If not, against the same thing, you just keep it in 4 decimal places. But for the table, for sure, normally I just write it in decimal places to make it consistent. Okay. And please pay attention to the decimal places. Don't follow this one. It's better that just keep it in 4 decimal places if the question didn't mention it. Okay, so the last one, the last example I want to discuss with you is the Gauss eliminations method against the thing. So as you notice at here, x1, x2, x3, x4. One more thing, if let's say that as you notice at here, maybe the equation is not arranged at here, maybe x2 plus 3x1 equals to something. So just the thing, you try to rearrange it based on the variable. Okay, maybe some tricky at here, just rearrange it based on the columns before you proceed the calculation. So just the things that here, the first step, we write it as the augmented equation. So x1, x2, x3, x4, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 0, 0, 0, 0, 0, 0. Okay, we don't have the value. We just write it down as the zeros at here. And then if you are confused, maybe you can write it as x1, x2, x3, x4, and then you just fill in the coefficients at here. So up to you. For me, I prefer to write it down and then gather the coefficients at here. Okay. And then Tuesday, I will discuss with you the project instruction. So maybe you can find your group member first. So once I discuss with you, you may just okay, normally I just open the author and then let you all to decide on your own. So maybe you can have a discussion with your group member first, who you want to be in a group. So on Tuesday. Okay, so from here you get this one against the thing based on the, where is the thing? Okay, based on the main diagonal, that means that you are going to eliminate this element, and also this element. So for the first step, as refers to here, this one is 0, so actually no operations at here. So for the second row, negative, the row, the coefficient of the row you are going to eliminate. So as refers to here as the second row, 3 over the diagonal elements as 1. So it refers to here diagonal elements from the first row plus the element from here, this from the second row is going to be the second row. Why I know that these two no need to do the operation since this one is zeros already. Or I show you the thing, if let's say that you want to eliminate these elements, negative zeros of 1 R1 plus R3 is going to be the latest row 3. From here you know that zeros times anything, this part is going to be 0. So R3, it becomes the R3. That means that just remains the value at here. So nothing changed at here. So that is why no need to do the operation for these two rows since the coefficients at here is 0 already. Okay, so this one I just share with you during exam. No need to write it. Okay, don't waste your time. So we proceed for the first one from here, A, B, C, D. So from here, E as A, this one as B. Against the same thing, insert this part into your calculator. Okay, once you insert this part into your calculator, then now you press the calculate button, and then now the value of A as 1, value of B as 3, you may get the latest value as 0. If not, against the same thing, please recheck these equations or whether you insert the wrong value at here. So just the same thing for the first row, you just write it back. So from the questions, you know that 12001. Okay, so you are going to get the value of 0 for sure. If not, we check it. And then now we move it to the second column. So second column, now the value of A is 2, value of B as 4, you may get the latest value of B as negative 2. And then we move it to the third column, A as 0, B as 5. You may get, okay, you may get E as same since this one is 0. So multiply with 0. So you just remain the value. And then here 0, 0 for sure you get E as 0. But remember the right hand side. So the value of A as 1, the value of B as 0. You may get it the value as negative 3. So here I just write it down. And then for the third row and the fourth row, so no operations at here, so we just rewrite it back. Okay, no need to do anything, just rewrite it. Since as reference to here, I show you already, R3 is going to be the R3, so just keep it same at here. Okay, so once you get this matrix form against the thing as refers to here, the main diagonal. So now you are going to eliminate this element since below the column ones or the operation is done already. Now it refers to the second column. So against the thing, the element is going to be eliminated over the diagonal element. So it refers to the second columns, the diagonal elements at here is -2. So this one refers to here from the second row plus the numerator from the third row. This is going to be the latest third row against the same thing. I just define it as A, B, C, D. So this one is B, this one is C. And then against the same thing, insert this part into your calculator and then you just press calculate. So from here, let me work. Okay. So for the previous two row, you just write it back at here. So 1, 2, 0, zeros. And then this one is 1. So 0, -2, 5, 0. Oh no. This one is -3. Okay, and then for the third row, just the same thing, refers to the calculator formula. So as refers to here, what is the thing? Okay, so it refers to here, the third one. So insert this formula into your calculator. B equals to 0, C equals to 0. For sure, you get E back as 0. And then when B equals to -2, C equals to 6, we will get E as 0 since the purpose for this formula, this element is going to be eliminated. And then just the same thing, when B equals to 5, C equals to 7, you get some latest value for the third row. And then when B equals to 0, C equals to 8, you get E as same since anything plus with 0, you get E as 8. Then remember the right hand side, and when B equals to -3, C equals to 2, you will get the latest value right here. And then for the fourth row right here, you just write it back since the eliminants is eliminated already. Just now I show you that remain unchanged, so just write it back here. So you will get it as 0, 0, 22, 8, and -7. And then the last row, you just write it back 0, 0, 10, 11, 3. Okay. So against the last thing, as refers to here, the main diagonal. So the last element is going to be eliminate A, B, C, D. So against the same thing, so negative, the element is going to be eliminated 10 over the diagonal element. So it refers to here the diagonal elements as 22. R3 plus R4 is going to be the latest row 4 at here. So at here is C, at here is D. Against the same thing, once you insert the calculator formula and then you press the calculate. So alpha C, alpha D at here. And then just the same thing, in this 3 row, the operation is done at here. So just rewrite it for the first 3 row. Okay, so you get it as 1, 2, 0, 0, 1, 0, -2, 5, 0, -3, 0, 0, 22, 8, -7, 0, 0, 0, 81, 11, 68 over 11. So from here, oh no, sorry, is it better I discuss with you? Okay, against the thing, insert this into the formula, value of A, value of C, value of D from the, okay, when we calculate the value for the latest value of D, insert the value into a calculator, write it down the latest value of D for the next matrix, and then same go to here based on the column. So value of C 0, value of D 0, and then this one value of C 22, value of D 10. So for sure you will get this value as 0. If not, again, the thing, check the equation, check whether you insert the correct row or not, and then the fourth column set here, value of C 8, value of D 11. Same go to the right hand side, C -7, D 3. So you are going to get all this value. If this one not equals to 0, please recheck it. Remember the purpose of the calculations formula here. Okay, so in this way, against the thing, you check it whether the elements below the diagonal as zeros or not. Yes, all the things as zeros already. So you may just rewrite it in equation. So from here, yeah. Okay, if you are confused, maybe you can write down the variable first. So from here, just rewrite it in equation. So x1 plus 2x2 equals to 1. Negative 2x2 plus 5x3 equals to negative 3. And then 22x3 plus x4 equals to negative 7. 81, 11x4 equals to 68 over 11. Just write it in equation. And then once you get this one, we apply the backward substitution. During exam, you don't know whether this one is backward or forward, also doesn't matter, just proceed the calculation. So from here, this one, 1, 2, 3, 4. Okay, so from the last one, since at here there is only one variable at here, so from the last equation after rearrange it, so 68 over 11 divide with 81 over 11, or you just use the calculator formula as 11 over 81. Okay, both is acceptable. So left hand side move it to the right hand side as the division, so you will get it as, why is the thing at here, 68 over 81. Okay, have a try on your own. And then from the third equation, so substitute the value of x4 at here. So 20x3 plus 8, this value equals to negative 7. So just the same thing. Remember that when we move it to the right hand side, multiplication become divisions, so summations between as the subtractions at here. So after rearrange, you will get this value. So please remember that, have a try on your own. And then from the second equation, substitute the value of x3 at here, you will get the value of x2. So just the same thing. So you will get it as negative 19 over 324. And then from the first equation, so just the thing, insert the value of x2 at here in order to obtain the value of x1. Okay, once you get all the value at here, okay, again, it's up to you. You want to use the general variable, or you want to write x1, x2, x3, x4. So remember that previous one is the backward substitution. So just write it down, the value based on the sequence. So x1 refers to this value, and dash refers to the previous one, negative 19 over 324. Okay, if possible, please write in columns. It's easier for me to mark in your paper. Okay, so that's all for today. If you have no questions, you may leave the meeting. And then if you have any questions, you may ask me now. Goodbye.
Thank you, Doctor.